Okay, we're in section 4.2 today, greatest common factor. Okay, you can put GCF, that's fine. The greatest common factor is the largest common factor of two or more numbers. Okay, so write down that definition. Alright, so there's two ways to find GCF. Okay, the first way is to list the factors of the numbers. Okay, so when we list the factors, that's just like what we did yesterday. Alright, so listing factors, let's start with numbers 16 and 28. The numbers 16 and 28. So if I have these numbers, I want to start off by listing the groups of numbers that can be multiplied together to give me 16. 1 and 16, 2 and 8, and 4 and 4. Alright, and then we're going to list out the factors for 16. 1, 2, 4, 8, and 16. Now let's do the same thing for 28. I want you to go ahead and write out the groups of numbers that can be multiplied together to give me 28. So for 28, 1 and 28, 2 and 14, and 4 and 7. Now we list them out, okay? And now we're looking for the factor, the biggest factor that both numbers share. Okay, so 2, both numbers share a 2, but is there a bigger number? What is it? It's 4, so my GCF is 4. Alright, so there's no math that I have to do. Once I list out the factors, I just find the biggest number that both of them share, and I go from there. Alright, now let's do, what if we had 3 numbers, okay? I'm going to go ahead and list out the groups of factors for you, just because, you know, this is the part that we've already been doing quite a bit. Alright, what I want you to do, you don't even have to copy down what I have on top. Okay, you don't even have to copy it down. I'm going to assume that you know how to group them. Everybody know how to group them? Okay, what I want you to do is, from these factors, I want you to list them out. For 24, 48, and 96, you see how I've started to do it on the bottom? I want you to go ahead and list them out. Alright, so let's list out our factors. 1, 2, 4, 6, 8, 12, 24, 48. Listing them out. Alright, now that I have all my factors listed out, now I'm going to see what's my common factors. Well, I've got 2's in common, and 3's in common, and 4's in common, but what's the biggest number that I have in common, Larry? 24. So my GCF is 24. Alright, so whenever I'm using factors to determine GCF, I don't have to do any math. I just look for the biggest factor once I list out my factors. Alright, now, now to answer the question that you all have been asking, yes, you can use prime factorization to also find the GCF. And you want to do that, when you have really big numbers, like, say, 180 and 126. Those are numbers we're going to start with. Obviously, we don't want to list all the factors of really big numbers. Okay, so most of the time we're going to do prime factorization to determine the GCF. Now, my preference is to do upside down division because I believe that it leaves less room for making a mistake. If you prefer factor trees, go right ahead. You're not going to miss any points for using a factor tree. It's totally up to you. But I'm going to use upside down division. So what's a prime number I can divide into 180? 2. Very good. So I'm going to divide by 2 to get 90. Then divide by 2 again. Then divide by 3. 3. And now I'm done. Just like that, I'm done. So upside down division is much quicker than factor trees as well. And remember, as long as you have all prime numbers on the outside, then you've done it correctly. Alright, so we've got 2 goes into 126, 3, 3, 3, and 7. Now I want you to go ahead and list out the prime factors in order from least to greatest for both numbers. So 2 times 2 times 3 times 3 times 5. We're going to leave them spread out, so we're not going to write them as powers. 2 times 3 times 3 times 7. Now that we have them listed out, now I need to circle my numbers that I have in common. I can't just circle one of them and say that's my GCF like I did with factors. I need to now circle my common factors that I have. Okay, so I have a group of 2's and 2 groups of 3's. For each group, I'm going to write it one time in my GCF, and I'm going to multiply those numbers together. All right, so what's 2 times 3 times 3? Larry? 18. Very good. So 18 is my GCF. 18 is my GCF. All right, so just kind of pulling it all together. Now I want you to do your turn now. We're going to do 4 of them, numbers 1, 5, 7, and 9. Okay, so number 1, what's my GCF?
4.
4. Should be 4. Very good. All right, number 2, what's my GCF? 7. Very good. Or I'm not number 2, number 5. It is 7. Very good. It's 7. All right, man, it's taking forever. Okay, GCF is 7. Y'all still need another minute to work on 7 and 9?
Yes, ma'am. Yes, ma'am.
All right, so number 7. Anybody find the GCF? What's the GCF on number 7?
36.
No, not 36. Not 90.
15.
It is 2 times 3 times 5. 30. 30. Did you get the prime factorization correct? Let's see. It should be 2 times 3 times 3 times 5 and 2 times 3 times 5 times 5. I group my common factors together. I multiply them together one time. All right, what about number 9? What did you get for number 9? All right, we should list out our factors. So I have 2, 2, 2, 3, 5, and then 6 2's and a 3. So circle my 2's and my 3, multiply them together, and I should get 24. All right, so you might want to rewatch this part of the video if you're still struggling with GCF, just to make sure that you know how to do it. Now, there's just one real quick thing that we need to go over, and that's the term called relatively prime. Relatively prime. Say I do the prime factorization of 2 numbers, and I just want you to pay attention to the screen real quick. Okay, don't worry about writing them down just yet. Look at the screen. So here's my prime factorization. Well, what do you notice about my prime factors? What do you notice? Do you have any of them in common? So Peyton, this is what you were asking earlier. I don't have any factors in common, except what is the factor that they always have in common? It's a 1, okay? So I'm always going to have a GCF. But sometimes, if there's no other common factors, my GCF is going to be 1. And anytime this happens, I say that the numbers are relatively prime. So make sure anytime that you have no common factors that you identify those numbers as being relatively prime and that you tell me that the GCF is 1. All right, any questions about what happens when numbers don't have anything in common? Any questions? Anything? Okay, since it's a lot of writing, I'm not going to ask you to write all of this down, but I want to show you what happens when you find the GCF. Everybody look up here. When you find the GCF of more than 2 or 3 numbers, so say here we've got how many numbers that we're finding the GCF for? We have 4. So what happens when you list out the prime factorization? This is very important for you to know for GCF and for your homework tonight. When you list out your common factors, the factor must be common in all 4 numbers in order for it to count as a group. So you see, for the number 2, I only have a 2 in 3 of the numbers, correct? Mm-hmm. So since it's only in 3 of them and I don't have a 2 in 153, it cannot count as a group. The only factor that can count as a group is the number 17, so that's going to be my GCF. Does that make sense? Okay, so you have a couple of these on your homework tonight where you have more than 2 numbers. The factor has to be in all of the numbers to count as a group. Now, what if I have more than 1 group? What do? I write it one time in my GCF and multiply the numbers together, and that gives me my GCF. So if you understand that, that's everything you need to know for 4.2.